Good morning everyone. I am Dr. Lakshmi. I'll be now explaining as to the applications of diffusion problem. Now this is a case that is where we are going to now apply the concepts that we have learned till date. Now the problem which is in an extended version or which requires the application of the earlier understanding includes that we need to prove that the mutual diffusivities of species A and B are equal if gas mixture is ideal when the total pressure in a system is constant. Now this is a problem pertaining to a binary mixture where we have only the two components, that is the species A and species B. Now if we recall what we had studied earlier, that is the Fick's first law of diffusion states that the diffusional flux is a function of the concentration gradient. Now for defining the total molar flux, which is N, is again for a binary system is a function of the molar flux of component A and B and the mole fraction and the diffusional coefficient. Now, so utilizing this, we'll now try to derive an expression for the flux of each of the components present in the binary system. Now look into this, that for the component A of the binary gas mixture, the flux for component A may be expressed using this expression. Similarly for component B, it is this. Now it's an important aspect which we need to note over here is this is CdAB for component A and for component B it is CdBA. Now since we know that the total molar flux is a summation of the molar flux of component A and the molar flux of component B, again the mole fraction of component A and the mole fraction of component B both yield to a sum of 1. Now utilizing these two expressions for the components of the binary mixture, we get the expression CdAB dYA with respect to dZ and which is equal to minus CdBA into dYB by dZ. Now again, when we differentiate the mole fraction expression with respect to Z, then we get dYA by dZ plus dYB by dZ. Now since this is a constant, so the differentiation of this is 0. Rearranging the terms, we get dYA by dZ is equal to minus dYB by dZ. If we substitute this equation in our earlier equation, that is equation 4, what we get is that dAB is equal to dBA. Now from this equation, it can be explained that for a binary gas mixture which has the components A and B, the diffusivity of A in B equals the diffusivity of B in A. Hence, the question that we had needed to prove that the mutual diffusivities of species A and B are equal. That means the diffusivity of A into B and B into A for a binary gas mixture, if it is ideal, is same provided the total pressure of the entire system is constant.